So let's talk about min-max word problems. And so as it says up here in this first paragraph I wrote down, it says when looking for extreme values, it's often helpful to create a quadratic equation to model the situation and use the minimum or maximum of the parabola to find the solution. So this is a nice little simple exercise here to kind of give a little value to all that parabola stuff that you've done. You know, all parabolas have a minimum or a maximum, and that minimum and maximum is something that can be pretty helpful to us. So let's do a couple fairly simple examples just to kind of demonstrate that. So the first example I have here says two numbers differ by 12. Find the least value of their product. So if I go ahead and just write down what I know, two numbers differ by 12. So what I can do is I can just simply write something as simple as x minus y equals 12. Two numbers differ by 12. And then also it says find the least value of their product. Well, if their product, product means multiply, so it means their product is equal to x times y. So what I want to do is this. I'm going to try and create a quadratic equation based upon this. And so the way I'm going to do it is this. I'm going to take this first equation here, and I'm going to set it equal to x or y. So in this case, let's just set it equal to x. So x is equal to 12 plus y. And what I'm going to do then is I'm going to take this value and I'm going to substitute it over here into this other idea because it says to find the least value of their product. And so I'm going to take this value and plug it in over here. So when I do that, I'm going to get, let's see, 12 plus y times y. If I simplify that, I get 12y plus y squared. Or if I switch it around, y squared plus 12y. Now, I want to know, so what I've done here is I've created a quadratic equation. All right, now normally I know it says like x equals or y equals, but it doesn't really make a difference right now. It doesn't even matter that the fact that I'm using y here versus x doesn't make any difference. If this is a quadratic right here, I should be able to figure out the minimum or maximum value of this quadratic. Well, how do I do that? Well, if you remember, okay, if we kind of take a look at just a made-up picture here, if this is a parabola, okay, where is the minimum or maximum at? Well, in this case, it would be a minimum, and it's down here, at this spot way down here. Well, what is that point? Well, that point is the vertex. Okay, and the minimum in this case is the y value of the vertex. Okay, so that might be something that's kind of helpful for you to write down that the min or the max is the y value of the vertex. So our main task here is to figure out what the vertex is. Well, let's do that. So how do I do that? Well, I'm going to put this into graphing form. So the way I'm going to put it into graphing form is I'm going to take a look at this and I'm going to go through and do a little completing the square, if you will. So to complete this or make this a perfect square trinomial, I'm going to take this number, divide it by 2, and square it. So if I take 12 divided by 2 and square it, I get 36. Now I can't just add 36, so to balance it out, I'm also going to subtract 36 right here. Factor. So that's y plus 6 times y plus 6. So I'm factoring this minus 36. And then so it's equal to y plus 6 quantity squared minus 36. So if we come over here, what's my vertex? Well, my vertex, okay, of that would be -6, -36. And so how does that help us? Well, it helps us a couple ways. One is this y value right here. Okay, this tells us the least value of their product. Okay, that's what that tells me. Okay, well, what does the negative 6 tell me? The negative 6 tells me what one of the values is. Okay, so it tells me that one of the values is negative 6. Well, if there are two values, okay, two numbers differ by, by 12, that means if one of them is negative 6, the other one has to be 6. Okay, so my two numbers, okay, so my two numbers are 6 and negative 6. They differ by 12, and the least value is negative 36. So there aren't any other two numbers that differ by 12 who have a smaller product than negative 36. And you can try that. You know, if let's say 7 and 19, or negative 5 and was it negative 7. Negative 36 is the smallest product. Okay, so as we look at that, okay, some of the keys to that are the fact that when I go through and do all this, this value right here is going to tell me that's my extreme value, that's my minimum or maximum, and this number right here will tell you what value gets you there. Okay, so let's try another one. That's a lot of stuff right there. So this one says the sum of two numbers is 22. So I'm just going to write that down. Whoops, let me change the color back. Okay, so the sum of two numbers is 22. So x plus y is 22. So what is our greatest possible product? So this is telling me that we're looking for a product. It'll be x times y again. So let me set this equal to, I'm going to set it equal to x this time again. So it's 22 minus y. I'm going to substitute it over here. So when I do that, I'm going to get 22 minus y times y. So I'm going to simplify that, and if I simplify it and kind of switch it around, I get negative y squared plus 22y. Okay, so we need to figure out what the vertex is. So we're going to put it in graphing form. All right, so what I'm going to do is, now you notice here that we have this negative value here, which you can't have when you do complete the square. So I'm going to factor that out. I get y squared minus 22y. Okay, so now what do I have to add in here? Well, I'm going to take my 22 divided by 2 and square it. So that'd be 121. But remember, that's not really a 121 because it's negative times 121. So it's actually a negative 121 that I added in there. So to balance it out, I'm going to add a positive 121 in. I'm going to factor. This is going to be y minus 11 times y minus 11, or y minus 11 squared. Okay, so my vertex here is at 11, 121. So, what are my values here? Well, let's see. If the 121, this right here is my extreme value, and 11 is my first number. So up here it says x plus y equals 11. So if one of my values is 11, okay, then my other value is also 11. So those are my two numbers. Okay, and it says what's their greatest possible product? Well, their greatest possible product is that extreme value 121. Okay, so again, there's no two numbers that add up to 22 that will have a bigger product than 121. Okay, so let's try another one. Got a couple others down here. Okay, what about this one? Okay, it says a rectangular yard has a perimeter of 14 feet. What's the maximum area of? Ooh, I don't know why it says quilt. It should say yard right here. Okay, so again, I'm going to come up with two different equations here. One of them, it says the rectangular yard has a perimeter of 14 feet. So if we're talking about rectangular yard, let's call this x and this y. So the perimeter would be 2x plus 2y equals 14. And the area is, that's our extreme. So area, as we all know, would be x times y. So what would that be? Well, let's see. I'm going to go through and again, I'm going to substitute. So let's say in this case, I go through and, I don't know, I substitute for y this time. So this would be 2y equals 14 minus 2x. So y is equal to 7 minus x. So if I were to take that value and plug it up here, I would get x times 7 minus x. Simplify that. 7x minus x squared. So negative x squared plus 7x. Okay, I'm going to try and figure out the vertex of that. So again, I'm going to subtract, or probably factor out a negative. Okay, so now I got to figure out what I'm going to add in. Well, let's see. I'm going to take this negative 7 right here, and I'm going to divide it by 2 and square it. And if I do that, I get 49/4. But you need to remember, that's really not a negative. That's not really a 49/4 you just added in. It's actually a negative 49/4. So to balance it, I'm going to add a positive 49/4. Factor negative x minus 7/2 squared plus 49/4. So my vertex is 7/2, comma 49/4, which is also what I believe that's 1, 2, 12 1/4, something like that. Okay, so it's asking you what's the maximum area of the yard. Well, again, this right here is your extreme value. So the maximum area of the yard using those dimensions would be the fact that it would be max area would equal 12 1/4 yards squared. Okay, so we got one more. Let's try one more and then we'll call it quits here. It says, what's